Hello and welcome to Let's Design A Machines. So today I'm going to design this simple assembly of a conveyor belt. As you can see here, it consists of rollers, a frame, a flat belt, and a spore gear. After designing this assembly, I'm going to make a motion study that looks like this one. First, I'm going to make one of the rollers. Open a new part. Choose extruded boss. And it has a diameter of 50 millimeters. You can exit the sketch. And the length of it is 200 millimeters. Now I'm gonna make one of the shafts of this roller. Gonna choose extruded boss. Gonna sketch on this plane. And the shaft has a diameter of 30 millimeters and a length of 20 millimeters. Now I'm gonna mirror this shaft about a plane here, which I'm gonna do right now, to the other side of this ruler. So I'm gonna go to reference geometry. I'm gonna choose plane. I'm gonna choose for the first reference this face of the ruler. So the offset distance is right, but the direction has to be changed. I'm gonna check this option to change it. Flip offset. I'm gonna go to mirror. For the mirror plane, I'm gonna choose this one. For the features to mirror, I'm gonna choose this shaft. Gonna hide this plane. Now I'm gonna make a contact surface between the roller and the spore gear that you have seen at the beginning of this video. So I'm gonna make extruded boss. I'm gonna choose this face to sketch on. Gonna sketch a circle that has a diameter of 60 millimeters. Now under direction 1, gonna choose up to surface. Gonna choose this one. And I'm gonna go down to merge result. I'm gonna uncheck this box. And choose OK. Now I did that because I want to hide this extruded boss. If it was unchecked, the whole part will be hidden. But I'm gonna uncheck this option. I'm gonna call this contact surface. Now I'm gonna add an appearance to it. I'm gonna choose metal, steel, polished steel. I'm gonna save it. In this file, I'm gonna call it roller. Now I'm gonna make the frame. I'm gonna choose a new part. Go to extruded boss. I'm gonna choose the right plane. I'm gonna make a rectangle. And this rectangle has a dimension of 20 millimeters width and the height of 80 millimeters. Gonna make a center line here. Gonna make a distance between them, which is 100 millimeters. Now I'm gonna go to mirror entities. So in the options, I'm gonna choose now entities to mirror. I'm gonna choose this rectangle, and this rectangle is gonna be mirrored about this line. I'm going to exit the sketch and I'm going to give it a length of 400 millimeters. I'm going to make the hubs of the shafts. I'm going to go to extrude cut. Going to choose this face for sketching. Going to choose a center line. I'm going to sketch a circle here. It has a diameter of 30 millimeters. And the distance between one of the frame and this hub is 25 millimeters. Gonna exit the sketch. So under direction 1, I'm gonna choose through all both. I'm gonna make a linear pattern. For direction 1, I'm gonna choose this edge. For spacing, I'm gonna choose 70 millimeters. And for number of instances, I'm gonna choose 6. I'm gonna go down to features and faces. I'm gonna choose this one. Gonna add some appearance to it. Gonna choose aluminium. I'm gonna save this part. I'm gonna call it frame. Now I'm gonna make a new assembly. Gonna insert my parts. So you can see here the frame is fixed, which is okay. Gonna now constrain the movement of this roller using mates. Gonna choose this face for concentric mate, and this face for coincident mate. Now I'm gonna make a linear pattern for the roller. Gonna choose this edge of the frame. Spacing is right and the number of instances is also right. I'm gonna go down to components, to pattern. I'm gonna choose this ruler. You can see it's patterned but in the wrong direction. So I'm gonna go up. I'm gonna reverse the direction of this pattern. Now I'm gonna make the belt. I'm gonna go to insert, assembly features, belt and chain. I'm gonna choose this ruler and this one. I'm gonna go down to properties. I'm gonna check this box, create belt part. But first I have to save this assembly. I'm gonna call it conveyor belt. So now our belt is represented by this line. I'm gonna make a part. Gonna right click on this belt part. I'm gonna choose edit part. I'm gonna click on this line of the belt. Before I'm gonna choose the extruded boss and then click on this line. Under direction 1, I'm gonna choose up to surface. I'm gonna choose this one. And I'm gonna check the direction 2. I'm gonna make it also up to surface. I'm gonna go to thin features to make a thickness for this belt. I'm gonna give it a thickness of 2 millimeters. Now I'm gonna exit this edit component. Gonna hide this line. I'm gonna add an appearance for this belt. I'm gonna go down to rubber, mate, and drag it and drop it here. Then choose for the part which is the belt. Now I'm gonna insert the spore gear. Gonna go to design library. Gonna click it. Gonna go to metric dimensions. Then I'm gonna go to power transmission, check, and then choose gears. Spore gears, you have to drag it and drop it here. So this is the dimensions of the spore gear, which is okay. I'm gonna exit this gear editing. Now I'm gonna make some mates for this gear to constrain it and put it in the right position. I'm gonna choose parallel mate. I'm gonna go to top plane and then this face of the gear. Now can check OK. Now we can see here it's not constrained yet, or it's not put in the right position. So I'm gonna go to ruler, gonna go down to this contact surface, gonna show it. As you can see here, this contact surface will be the contact surface actually between the rulers and the spore gear. So since the belt doesn't go anywhere or it doesn't rotate along this conveyor belt, so I'm gonna fix it. Right click on the belt and fix it. And then I'm gonna go to mate. I'm gonna mate this gear to this ruler to position it only. Then I'm gonna suppress this mate later on when I'm doing the motion study analysis. I'm gonna check OK. I can hide the frame to see the gear and the roller more clearly. Gonna drag it. Okay, I'm gonna show the frame again. I'm gonna hide this contact surface. Not suppress it, I mean hide it only. I'm gonna unsuppress it, gonna hide it. We can see it's a clear view. Now I'm gonna make the motion analysis. But before I'm gonna suppress this mate that I have done. which is the tangent mate. I did it to position actually this spore gear. I'm gonna make the motion study. I'm gonna go down to motion analysis. Gonna right click this option, this orientation and camera view, and disable this playback of view keys so that I can position or view my assembly the way I want while the calculation is running. So now I'm gonna put a motor here, a rotary motor. I'm gonna go down to direction. I'm gonna reverse this direction to clockwise. I'm gonna go to speed, make it 20 RPMs. Gonna check OK. Now for the contact, I'm gonna go to use contact groups and check this box. Gonna first choose this spore gear and then gonna choose these rollers. Gonna go down to materials, gonna change it to greasy steel. Gonna check OK. Now I'm gonna enable actually the gravity. I'm gonna make it along the Y direction. We can see the direction of gravity displayed here. Now the assembly is all set. Gonna run the calculation. Now the calculation has finished. We can go to results and plots to see some results. For example, I want to know the velocity of this gear along this conveyor belt, which is the linear velocity. So I'm going to choose in the subcategory linear velocity. Then I'm going to, for the component, I'm going to choose along the x-axis. I'm going to choose this face of this gear. I'm going to check OK. Now we can see the plot for this motion analysis. Now, if we want the average velocity for this gear, we can right click on this plot and go to export to CSV and call this velocity. Save it. Go to the file, and it is an Excel file. You can open it. We can see here the time displayed in seconds and the velocity displayed in millimeters per second. I'm gonna choose one of these cells. I'm gonna click. I'm gonna type equals, and then I'm gonna type average. We can see a window here pops up. I'm gonna choose average as a function. I'm gonna choose this column. I'm gonna check OK. Now we can see that the average velocity is 60 millimeters per second, 0.6. So if we compare this result with the equations that we studied in the the dynamics, we can see that there is difference between them. That's due to the acceleration of the accuracy. Sorry, the accuracy of this motion analysis. We can increase this accuracy by increasing the frames per second and going to check this. Use precise contact to increase the accuracy, and also we have to um, increase this accuracy. We should make it high, but of course this will take a lot of time to run this calculation. And there's another reason for this difference: the fact that this bore gear it doesn't have a contact with this flat belt. The only contact is between those rulers. So these two reasons why there's a difference between this equation and the results of SolidWorks. Okay, this is the end of this video. I hope you enjoyed it, and thanks for watching.